Let's begin our journey with the subject solid-state devices, which is one of the core subjects in electronics. In today's class, we will discuss about the syllabus that we are going to cover, and from next class onwards, we will start our topics. I have divided the subject into 4 chapters. In chapter 1, we will study the basics of SSD. So chapter 1 is about basics, and under this chapter, we will first study the atomic structure of semiconductor materials. We don't have to study in detail about the atomic structure of different materials. We just need a concept of atomic structure of semiconductor materials. Then we will go for the energy band diagram of semiconductor materials. We will study how we can draw the energy band diagram, and we will study different energy levels in the case of that energy band diagram. Then after that, we will go for the Fermi-Dirac probability function and Maxwell-Boltzmann approximation. Under this Fermi-Dirac probability function and Maxwell-Boltzmann approximation, we will study the probability of finding an electron in an energy level, and also we will study to write the carrier concentration equations in the case of semiconductor materials. Then after that, we will go for different doping techniques that is used in the case of semiconductor materials and the corresponding carrier concentration equations after doping. And then finally, we will study about the electric field that is developed in the case of semiconductor and the equations for that electric field that is developed in the case of semiconductor. Then we will move to our chapter 2. In chapter 2, we will discuss the p-n junction. So chapter 2 is all about p-n junctions. Under this, we will first study the energy band diagram of a p-n junction. And after that, we will go for the current and related equations that comes in the case of p-n junction. And then we will study the junction and diffusion capacitance in the case of p-n junction. We need to study the basic idea and equation of these capacitances. Then we will go for the small signal equivalent model of p-n junction. And then finally, we will study the diode transient response. Then we will move to our chapter 3. Our chapter 3 is about BJT. And under chapter 3, we will first study the current flow mechanism and corresponding equations in BJT. We will mainly discuss this using the active mode of operation. Then we will go for law of junctions. And after that, we will go for the minority carrier distribution of a transistor in active mode. And here also we are discussing this considering the active mode of operation. And then we will study different breakdown mechanisms in BJT. And finally, we will study the small signal equivalent models of BJT. And then we will move to our final chapter. Our chapter 4 is about MOS capacitor. So these are the topics I am planning to cover. There comes some miscellaneous topics also that we will discuss in between or after completing all these chapters. We will discuss that. In each chapter, after completing each topic, we will discuss the previous year's GATE questions asked from that topic. So after completing each theory part, we will discuss the problems from that topic, so you will be able to understand that topics completely. Now the textbook that I am using as reference is the Semiconductor Physics and Devices by Donald Niemann. I am winding up the discussion of syllabus here, and from the next class onwards we will start our topics.